Hi guys, Dr. Betts here. We're now going to do chapter 1.3, Math Counts. Again, don't worry about math. It's really not that hard. Everyone thinks it is. It's not. I'm not a big fan of math either, but I can tell you the math that we're going to do in chemistry class is really not that hard, and you guys can all do this. It may just take a little practice. All right, so of course in science we measure stuff, and in science we use the metric system almost exclusively. Now, we are going to talk a little bit about the English or the American system and how to convert out of it. It's very simple as long as you're given the conversion factors. It's very, very simple. All of this stuff is simple, okay? Before we get into that, there is, of course, the System International. You may have heard of it. It's basically the metric system that's been standardized. So in the SI system, the standard unit for mass is the kilogram. The standard unit for volume is the liter. And the standard unit for length or distance is the meter. It's just a standardized metric system. So I'd, in essence, just call it the metric system because that's pretty much what it is. There are differences, but don't even worry about those. Now, the metric system is great because it uses prefixes to define the unit. Now, we know a base unit. For example, if we look at this table, we know there's a base unit for length, which is a meter, volume, which is liter, and mass, which is gram. We know these things exist. If we want to do measurements for, say, long distances, we probably want to use kilometer. What does kilo mean? Kilo means 1,000 meters. Okay? So a kilometer is 1,000 meters. But 1 kilometer is equal to 1,000 meters. And that's if you look at the table, we're going that way. Okay? So 1 meter equals 1,000 kilometers. Hold on, Dr. Betts. You really didn't just say that there are 1,000 kilometers in a meter, did you? Because I know you actually meant that there are 1,000 meters in a kilometer. I know that's what you meant. Continue. Because if you look at the multiplier, we're multiplying it by 1,000 to get there. Now, if you want to go smaller, say you want to go this way down the chart, we know that 1 meter equals, well, we're dividing by 10 now, not multiplying, dividing. So if you divide 1 meter by 10, you'll get 0.1 decimeter. Now we have to use the prefix deci. Deci is basically means divide by 10, essentially. Now if you want to go 2 down, now we've got to divide by 100. Now 100 is centi. So 1 meter equals 0.00, oops, sorry, too many zeros. 1 centimeters. Okay? Now, again, if we want to go from here to here, we have to divide by 1,000. So 1 meter equals 0.001 millimeter. And that's how the system works. Okay? You're always dividing by a 10. Either 10, 100, 1,000, 10,000. You're always dividing by a multiple of 10 or multiplying by a multiple of 10. Okay? This is how the system works. So the prefixes tell us either how much to divide by or how much to multiply by. Okay. I get it. Everyone gets weirded out by the metric system that this happens. So what I want to do is I want to take a little bit of time here and I want to just set up a little table for us. Okay? So let's say we have mass. Base unit is gram. We have length. Base unit is meter. And the last thing is volume. Base unit is liter. Okay. Now when you're working in metric, gram is pretty popular measurement. If you think about an American nickel, the coin, that's about 5 grams. So a gram is not very much. So let's say we have 1 gram, and the symbol for gram is G, lowercase g, equals 1,000 milligrams. mg is milligrams. All right? 1,000 grams equals 1 kilogram. kg is kilogram. Okay? That's how it works. Grams, kilograms, milligrams. These are the basic units for mass. There are other ones, as you saw from the table. There's decigrams and centigrams and all that. They're not used very often, so we'll just stick with these two for now. But you could use the table to get the rest of these. You could use it. Okay, they're there. Now, length is a meter, and generally speaking, we have 1 meter equals one. Oops, sorry. Let me fix that. Equals. I did it again. Sorry. 1 meter, got to have a unit, equals 1,000 millimeters. So notice milli means you divide by 1,000. Or in other words, there's 1,000 of these and one of those. Okay, 1,000 millimeters in 1 meter. 1,000 of the base unit, meters, equals 1 kilometer. Okay, and if you want, we can also do 1 meter equals 100 centimeters. And there's another one we can throw out here. 10 millimeters equals 1 centimeter. And these are the common equalities for length. There are other ones. There's lots of other ones. But these are the ones that are most commonly used. So I'm just giving you the common ones. Again, if you need to know other ones, just look them up. That's very easy to find. On an exam, you'll be given a lot of conversion factors, but you'll have to know the metric system. Okay, you have to know the metric system. So 1 liter equals 1,000 milliliters. And just for fun, 1 liter equals 10 deciliter. Okay, a deciliter is 1/10 of a liter. Or sorry, not 1/10, it's 0.1 liters. Which is 1/10, I guess. Okay? So that's how volume works. And those are the base units for volume. These are the equalities and conversion factors that are most often used. There are other ones, guys. Don't be fooled. For example, we'll get into the stuff a little bit later. For now, let's just move on with the math. All right. Now, quantities that can be related to each other are related with an equal sign. So these are what they call equivalent units. So 1 deciliter is 0.1 liters, or 10 deciliters equals 1 liter. Both saying the same thing. Now you can turn an equality or equivalent units into conversion factors. Now how do we do that? Very simple. Simply put one unit over the other. Like that. So I have 1 unit in the numerator, the other unit in the denominator. I have the other unit in the numerator, the other unit in the denominator. Essentially flipped it. Okay? Now notice the number 10 goes with the unit deciliter. And the number 1 goes with the unit liter. Notice that. That's a very important thing to see. Very common in these types of questions for people to put the right units everywhere, but the wrong numbers. Very, very common. So make sure you remember the units and the numbers are married. They always go together. And don't forget that, because if you do, it'll really cost you in terms of points on an exam. Okay? All right. So that's how you go from an equality to a conversion factor. Very, very simple. Very, very simple. So let's say I had 12 inches equals 1 foot. There's probably a conversion you're used to seeing, right? Well, I could put inches on top, foot on the bottom, or I could write foot on top, inches on the bottom. Now the number 12 goes with the inches. So the 12 would be here, the 12 would be here. The number 1 goes with the foot. There we go. See how easy that is? Now, I didn't even think about it. I just put one unit over the other, and then I inverted it, and then put the numbers where the units were. Remember, the units are married to their number. So the 12 went with the inches. The 1 went with the foot. That's how it always works, and it's very simple. Now, in order to do calculations in chemistry, we're going to use what's called dimensional analysis. This makes the math so easy. I mean, I can't even express how easy it makes the math, guys. Now, here's how you do it. Now, you can follow these steps. The steps are correct. Nothing wrong with the steps. I'm just going to say this. Whatever number you have here, whatever unit, you have here must go here. Whatever unit you need to convert to must go there. Simple as that. This is what you're starting with. Let me get my face out of the way here. This is what you're starting with. The unit. Remember, notice I didn't say number. The unit you're starting with. This is the unit you want to end up with. So the given unit always comes in the denominator of the conversion factor. The desired unit always goes in the numerator. Always. Always works that way. I promise you it will always work. Okay? But you have to let it. If you fight with it, it won't work. It'll fail. You have to let it work itself. Now, it takes practice to kind of get the confidence to do this, but it's always the same. Given unit, or where you're starting, is always written in the denominator of the conversion factor. Where you want to get to, or the unit that you're needing to convert to, always goes in the numerator of the conversion factor. And it will always work. It's so simple, guys. It's so simple. Let's see an example. Let me put my face back where I belong here. There we go. All right, how many grams of vitamin C are in a 100 milligram tablet? So we're given 100 milligrams of vitamin C. I guess we don't have to write that. Oops. 100 milligrams. We need to get to, or desired, equals grams. Well, we don't know how many grams are in this tablet. We have to set it up. Now, even if you can do this in your head, even if you have the background and metric to do this in your head, don't. Set it up. I can't tell you how many times people will just throw answers on a test and the answer is wrong. That's a 0. Okay? Set it up. If I can see where you made your mistake, and your mistake is a simple little calculator error or something, you'll get 9 out of 10. If I don't see any work, you'll get 0. You've got to show your work. Unless it's a multiple choice question, of course. Okay, so we're given milligrams. That's the unit we're starting with. The book or the question tells us 100 milligrams. Multiplied by, and put the line there, something. Something goes down here. Something goes up here. We don't know what those things are yet, but we know we want to get to grams. We know we want to get to grams. Let me get rid of the question marks here, guys. All right, so now, here we go. Whatever unit is written here, whatever that unit is, doesn't matter. Whatever that unit is, write it in the denominator. Why? Because mathematically they cancel. And that's good. We want to get rid of that unit. The unit you want to get to, this one and that one, are the same. They're the same. Okay? Now all we have to do is have the conversion factor for here. We have to know it. Now it's a metric conversion, so I know, and hopefully you will know too. You better know because you're going to need it for the exam. 1 gram equals 1,000 milligrams. That's the equality. That's how many grams are in a milligram. My face is in the way again, guys. Sorry about that. Let me just scoot over here. So now we're going to put 1,000 here, and the number 1 goes up there because, remember, the unit and the number are married. They go together everywhere. And then we put the number 100 over here. So then you grab your calculator. You can probably do this in your head. Take 100, multiply it by 1, divide it by 1,000. And you should get 0.100 grams. Now, I know a lot of you are thinking that's a lot of work for a simple question. Yes, this is a lot of work for a simple question like this. But guess what? I didn't get it wrong. I see so many times I'll see people do this in their head. Oh, so easy, blah, blah, blah. Throw an answer down. The answer is completely wrong, and they get 0. Do the work, do the due diligence, and you'll never be wrong. And you'll be happier for it. It'll be great, I promise. All right, another example. How many minutes are in a day? Or in 1.5 days, excuse me. Now, this is a tougher question. Why? Because I don't know how many minutes are in a day. I have no idea. Do you? Maybe you do. So let's write down given. It's 1.5 days. And we need to get to, or desired, if you will, equals minutes. We don't know. Have no idea. Got to figure it out. How am I going to do it? I'm going to use units. Days multiplied by something to give us minutes. Days go on the bottom, so the days will cancel, and then minutes will go on top. But wait a minute. I don't happen to know the conversion factor here. I don't know it. I don't know how many minutes are in a day. I have no idea. But I do know how many hours are in a day. So now we're going to get into a tougher example where there's actually a two-step conversion here because we don't know the equality between days and minutes. At least I don't know it. So it's going to look a little hard. And it is, in fact, it's a little bit challenging. But I want you to see exactly how you do this kind of question. It's not hard. You let the units work. Let the units always do the work. So we're going to start with the unit days. Oops. Let me get out of here. Back that up. Days multiplied by something that puts days on the bottom. Now I know the conversion to hours. I can get from days to hours. Hopefully that'll help. And now I can go from hours to minutes. Okay, so that's how you set this question up. Now notice I had to do a two-step conversion. Why? Because I didn't have the equality between minutes and days. That happens from time to time where you don't have all the information, so you kind of have to use what you know and try to massage the question to get to the answer. Now, I'm not going to lie, this is a tough question because it's two steps, not just one. Okay? Most of the time it's a one-step conversion. So just keep that in mind. 1.5. Now I know that there are 24 hours in one day. So put the number 1 down here. 24 goes up there. I also know that there are 60 minutes. Let's put min. 1 hour. So number 60 goes up here, and the number 1 goes down there. And that will leave us in minutes. I just put min. I'm running out of space here. Okay? That's how you'd solve this question. Now it's tough. It's tough because I had to do 2 conversions and not 1. So here you would just take your calculator, and I'll use my phone because I don't have a calculator. All right. Now let me see here. Calculator. Get out my handy dandy calculator. 1.5 multiplied by 24 multiplied by 60. And the answer is 2160 minutes. 2,160 minutes in 1.5 days. And that's how you'd solve it. Now, again, if you're having trouble with this, watch this part of the video again, see what I'm doing, and try on your own. It's really not that hard. And it kind of hammers home the power that the units have. All right. How many kilograms are in 165 pounds? Okay, so say you have a patient, weighs 165 pounds, and we're given the equality in the question. We probably need it. So keep that in mind. We probably need that equality. Okay. Given equals 165 lbs. Desired equals kilograms. All right. All right, guys. No problem. We have this. Given is pounds multiplied by something to give us kilograms. Okay. All right. Now, I know that the pounds must go here. How do I know that? It always works that way. Whatever's here is always here. The unit, that is, not the number, the unit. And the unit I need, kilograms, goes on top. Now, do we have a conversion factor or an equality that relates kilograms to pounds? And yes, we do. It's right here. All right. So this question became really easy. Now, where does the 2.20 go? It always follows its unit, right? 2.20 pounds goes here. 2.20. It's here, and now it's down here. Okay? Make sure you get that. That's important. And the number 1 comes up here. And the given, 165, goes right there. So take out your calculator. 165 divided by 2.2. 75 kilograms. All right. Now, We've done 3 examples here on how to use dimensional analysis to solve a math problem. They're not really math problems. They're dimensional analysis problems. Just use units. Make sure the units cancel. If you don't get it, go over these 3 examples again. Watch what I'm doing. Maybe mute it. Maybe what I'm saying is confusing you. Maybe mute me. Just watch. Okay? The units cancel. Every question's the same. The units may change. It's very, very simple, guys. Make sure you get this. It'll make all the math problems simple. I promise. All right, so with that, we're going to end the video here. We'll pick it up again in section 1.4, matter, the stuff of chemistry.